Hello and welcome to this Solidworks tutorial. In this tutorial I'm going to demonstrate how I created the crystal cutout design in my ceramics tableware collection pictured here by recreating a coffee cup. The final model and parts to follow this tutorial and all the decals are available to download in the description. To begin, I need to create the body of the cup. Starting a new part, I'm going to design this cup to be very oversized. So to begin, I'm sketching onto the front plane. I'm going to draw out the profile of the cup. Using the line tool, I'm sketching a 140mm vertical line. Sketch the top radius of the cup by 80mm and the cup base by 40mm. Train the ends of the line up with the spline tool, starting from the top point. Clicking onto the end point of the spline will cause the spline handles to appear. Pull these into place to create the rounded cup profile, and change the angles of the spline handle by typing into the parameters box here. This angle needs to be -90 degrees. And for the bottom spline handle, it should run parallel to the base, so change the angle to -180 degrees. With the profile complete, I can revolve the cup 360 degrees from this edge. Save the part as cup and close it. Starting another part, I'm going to create the crystal. This will be used to cut out of the cup. Sketching onto the front plane, use the polygon sketch tool. It doesn't matter where you draw it, but I like to use the axis as a starting point. Draw the polygon, making sure that it's 6-sided, and change its dimensions by selecting the inner circle of the polygon and type 40 into the radius box here. Extrude the sketch using Features and Boss Extrude and change the dimensions to 12mm in direction 1. Selecting the draft icon, change the draft angle to 75 degrees, creating the gem. Then before closing the sketch, click into the direction 2 box and the feature will automatically draft like the front extrude. So just unselect the draft icon and keep the dimensions of the extrude to 10mm. OK the feature. To soften the edges of the crystal, use the fillet feature and select one of the drafted edges of the part. Change the fillet dimension to 20mm and select the other 5 edges and OK the feature. Save this part as crystal and close it. The next stage requires an assembly. When you start a new assembly, the selection box will appear. Here I'm going to bring in the cup and crystal parts and select open. The begin assembly box will open on the left. My 2 components will show here. Before I start placing the parts, select the draw and pin icon here. This will keep the box open so that you can drop in multiples of the components. Start by dropping in the cup part, then click onto the crystal part and use the orientation options box to move the crystal around on the y-axis. I want the drafted part of the component to face the cup, and I just click to drop it near the cup. The component stays open because I have the pin icon ticked. You can change the degree at which the component will turn by typing it into the box and then clicking on the y-axis again to turn the part into place. I'm placing the other crystals in a diagonal pattern. I am placing 5 crystals and closing the insert components box while I move the part into place, otherwise it just becomes too complicated. To move the crystals into place, I start by just dragging the part up and into the cup. It's best to do this looking at the cup from the top view and making sure the back straight extruded end does not go into the cup. I use other views to help me place the crystals. It's okay that the crystals overlap, because if I don't do this there will be gaps in the cut later on. So push the parts close together, sweeping them around the cup. Bring them close to the top edge of the cup, but not too close, as it will get in the way of the lip of the cup. When I have the crystals approximately where I want them, I need to use Move Component and select Rotate. Here I'm not using any specific constraints, I'm just clicking and dragging on the back and the sides of the crystal parts so that they wrap around the cup, almost tangent to the cup profile and the centre. This part of the design can be the most time consuming, as the placement of the crystals is very important as it controls the final design of my cup. I'm making sure that I view the cup from all angles so that I don't push the crystal in too far, and I make sure that the crystals intersect enough like this so that there'll be no gaps in the cut of the design. Ensure the crystal parts are as far into the cup as you can get them without passing the extruded edge. Once I have moved all 5 crystals into place, I can bring in some more using Insert Components. Select Browse and select the crystal part again and open. When the part opens, remember to select the drawing pin so that you can bring in multiples of the component. Using the same techniques as before, rotate the part to face the cup, going around the profile. I've dropped in 5 more crystals, but I may not need to use them all. But once I move them into place, I can delete any extras. You can place the crystal wherever you'd like it onto the cup, but I like to place them in a diagonal sweep. This is so that when they are cut out, they create a more ergonomic surface for the hand to grip the cup. I make sure that I leave a gap from the base of the cup to the crystals for the cup ring later. Drag all the crystals until you are happy that you have covered all the gaps in the cup. I'm deleting the 10th crystal as I'm happy with the pattern as it is. Once I'm happy with the placement of the crystals, it's time to save the assembly, ready for the next step. I need to save the assembly as a part to create the combine. So going back to File, go to Save As, and when the Save As box appears, change the Save As type to Solidworks part, and the file name to Cup Test. The Geometry to Save option should automatically be on all components. Keep this option on and click Save. Keeping the assembly open, go to File and open Recent and select the Cup Test file. When the document opens, it will open as one whole part with 10 separate bodies. From here, I will be able to see if I need to move the crystals around more. To check this, I need to combine the crystals to the cup. Select the Combine tool in Features, and when the dialog box appears on the left, ensure that the operation type is Subtract. For the main body of the combine, I need to select the cup. This will highlight green. For the bodies to combine or subtract away, select all 9 of the crystal bodies. These should all highlight blue, and then OK the feature. This cuts away all the crystal bodies from the cup. As you can see, the first crystal has gone in too far, and some of the other crystals aren't close enough to cut away from the cup profile. So these will need pushing in further to fix this. So make sure you know what crystals you need to move. I'm closing the part without saving it and working back onto the assembly. Move the crystals that are causing the issues. I can see here that the crystal has gone into the cup past the extruded back, so I just pull this out a little. Then I'm dragging the other crystals further into the cup, so there are no gaps in my combine. Once I'm happy, I can save the assembly again and use the Save As option again, Save As Part, and save over the cup test. Opening the amended part, opening the amended cup test part, use the Combine tool again. This time, I should have no gaps in my cutout design. You may need to repeat the process several times until you're happy with the final result, but I've done this process many times, so I have more experience of what works and how to place the crystals, so just persevere and it will work. Now to make the part into a cup, I'm starting by softening the cutouts. Using the Fillet tool in Features, fillet all the inner edges of the cutouts by 5mm. If your preview of the fillet disappears, you may have missed a smaller edge, so just go back over the edges and check. If the fillet doesn't work, you may need to decrease the fillet dimension or go back into the assembly and move the crystals closer together, as there could be a very small gap that is affecting the fillet. Once all the edges are selected, OK the feature. Next, select the loop of the outer edge of the cuts. Reverse the direction of the loop and select the Fillet tool again. Fillet the outer edge of the cut by 5mm and OK the feature. Use the Save As option to save the cup with a new name. Now I could just shell the top of this cup and turn it into a beaker, but I want it to be a coffee cup. However, the issue with this will be that it is missing a handle to stop the cup user from burning their hands. To solve this problem, I designed the cup to be double-walled and therefore insulated. To do this, I need to create the inner cavity which will hold the liquid. To add a plane in the centre of the cup, I use View and select View Temporary Axis, which brings the cup centre axis into view. Select the right plane. I then use Reference Geometry and add plane. The right plane as my first reference point and the cup's centre axis as the second reference point. This gives me a new front-facing plane in the centre of the cup. Sketch onto this new plane. Use the Line tool and sketch along the top edge of the cup a 70mm line. Use the Line tool and sketch from the top centre of the cup. Draw a 70mm line along the top edge. Then draw a line centre again, 130mm through the middle of the cup. The next line is very important. Starting from the end point of the line on the cup edge, draw a diagonal line along the cup's profile. For this cup, the length of the line should be 120mm with an angle of 195 degrees. If the angle was any larger, the revolve cut will cut into the cutout design on the outside. For the next sketch, I need to use the Spline tool and drain up the endpoints. As I did with the cup profile, I am using the spline handles and changing the angle of the handles to run parallel to the lines, to ensure that the cut revolve profile is smooth. Remember to click on the end of the spline point and drag the end point of the handle to make the spline parameters box appear. From the bottom spline point, I change the angle to 90 degrees, and for the top spline point, I drag the point of the spline handle to alter the curve to where I want it, before changing its angle to 15 degrees. When I'm happy with the sketch profile, I use Cut Revolve and revolve cut the profile by 360 degrees from the middle of the cup, creating the inner cavity. Check that the cut revolve has not gone straight through the cup near the crystal cutouts. If it has, you may need to decrease the inner cavity angle. Before I shell the inner cavity of the cup, I fillet the top edges of the cup by 5mm. Now to shell the cup, look from the bottom and select the bottom face, and select the shell icon in Features. I'm going to shell the cup inwards by 4mm. With the cup shelled, I need to make sure that the outer wall of the cup is not intersecting the inner cavity. To do this, I just use the Section View tool here. I'm currently sectioning using the front plane. Use the triad and drag on the arrow. The section plane will move through the cup, and as you can see on my model, the two walls of the cup shell don't touch each other. To double check this, I also view the cup from the right plane section view. You can see the walls here are much closer together, but there's still space. I OK the section view halfway through the cup model, so I can check that the inner edges of the model are smooth. With the section view on, I fillet the foot of the cup edges here by 2mm each. With that done, turn the section view off by clicking back onto the icon. With my cup design finished, I can add a body of liquid to the cup. This part's very simple. Start a new sketch onto plane 1, drop down the sketch under the cut revolve feature in the tree. Select it so that it highlights blue and select Convert Entities. Now just add a line along or below the bottom lip edge of the cup and trim away the outer entities. You don't want to go past here as the cup would be too full. Revolve the sketch 360 degrees from the middle, unticking Merge Result. You can use Solidworks to work out the volume your cup can hold by going to the Evaluate tab and selecting Mass Properties. When the box appears, the data collected is for the whole part, so click the part in the blue box and press Delete. Then select the revolved body so that it highlights blue. Now I can see its properties. The volume of the cup is listed here. To convert it to UK fluid ounces, you can use online converters. Just copy and paste in the volume in cubic millimeters. Using this, I can see that my cup holds almost 38 fluid ounces. If you wanted your cup to be smaller, you can delete the shell feature like this and use the scale feature on the cup and the liquid using Scale by Origin. For this cup, I'm scaling by 0.6. This makes the cup 9.6 centimeters in diameter, making it much more realistic. Finally, shell the model again with a thinner 2.5mm wall. Double check the model with section view and fillet the bottom edges by 1mm. To complete the look of the model, I'm adding a white porcelain appearance to the cup, ensuring all faces are covered. For the liquid, I'm not going to add an appearance, instead I have decals. Clicking onto the top face and edit decal, I choose from a range of free images I found on the internet. I created these by simply cropping a circle view of coffee out of the images. Opening the decal, it should automatically fill the face as a label, so just OK this. With the model complete, I change the model view to shaded, where I can see the cup more softly. I render the model in Solidworks Visualize. This is where the decal makes the cup look very realistic. You can try different cup colours or decals to create a range of looks with the one model. Thank you for watching this tutorial.